only those orbits are permitted in which the angular momentum of the electron is a whole number multiple of h upon 2 pi, that is, this is the angular momentum, mvr is equal to nh upon 2 pi. Then the third is the energy is emitted or absorbed in the form of quantas of energy, and when an electron has to move from higher to lower orbit, it loses energy, and when it is moving from lower to higher orbit, it emits energy, and the amount of energy emitted or absorbed is equal to the difference in energy levels of the two states. Now, since energy cannot be lost continuously, an electron continues to move in a particular energy level without losing energy, and such an atom, state of the atom, is known as normal or ground state. Since an electron cannot radiate energy if no lower orbit is available, therefore the atom does not collapse. So, according to Rutherford's model, we had said that the atom will collapse, the electron will fall into the nucleus. But since the Bohr's model says that the energy cannot be lost continuously, so we cannot say that that atom will collapse. On gaining energy from an external source, the electron jumps from lower energy level to a higher level, and this energy state of an atom is known as excited state. And the excited state being unstable, the electron falls to the lower energy levels and it loses energy in the form of light radiations of suitable wavelength, and this accounts for the spectral lines in the hydrogen spectrum. Now, we have seen how the first drawback of Rutherford's model is overcome. Now, the second drawback was that Rutherford's model could not explain the line spectrum of hydrogen, but we will see over here that the Bohr's model could explain the line spectrum of hydrogen. So, let us see the line spectrum of hydrogen. The fundamental difference between Bohr's model and Rutherford's model is that Bohr's model is based on the concept of quantization of energy and angular momentum. Quantization means that a quantity can vary only discontinuously to get a specific value. According to Bohr, electrons can move only in certain permitted orbits with definite amount of energy and angular momentum. Thus, quantization is the keynote of Bohr's theory. Rutherford's model does not give an idea about the permitted orbits. So, let us see the achievements of the Bohr's model. The Bohr's model could explain the stability of the atom. It could help us to calculate the energy of various energy levels. We had seen the formula, and it could successfully give the interpretation of the line spectrum of hydrogen. Now, let us see the line spectrum of hydrogen. First is the stability. According to Bohr's model, electron does not lose energy as long as it revolves in a particular orbit. Also, it cannot jump from first orbit to the lower orbit as there is no orbit less than 1. This gradual loss of energy is not possible, and hence the atom is stable. Then we could calculate the energy by this formula. And third, this was the formula we have already seen, En is equal to minus 2 pi square m z square E4 upon n²h². We have already seen this. Then this model gave a successful interpretation of the line spectrum of hydrogen. So, the most remarkable success of Bohr's theory is that it provides a satisfactory explanation for the line spectrum of hydrogen. Now, let us see the line spectrum of hydrogen. How a line spectrum is obtained? The line spectrum is obtained by passing an electric discharge to hydrogen gas taken in a discharge tube. The emitted light is analyzed with the help of a spectroscope, and the spectrum so obtained consists of large number of lines, and lines appeared are in different region of wavelength. The entire spectrum consists of 5 series of lines and are named after the names of their discoverer. The Lyman series, the Balmer series, Paschen series, Brackett series and Pfund series. The Lyman series is present in the UV region, the Balmer series is there in the visible region, and these 3 series are there in the IR region. Although hydrogen atom consists of just a single electron, yet it gives so many spectral lines. This is because in a given sample of hydrogen gas, there are large number of atoms, and when energy is supplied in the form of electric discharge, many atoms of hydrogen are excited simultaneously, and electrons in different atoms absorb different amount of energy and are excited to different levels. The excited electrons are unstable and fall back to the ground state, and in doing so they emit different amounts of energies which are associated with different wavelengths. Now, let us see the line spectrum, and this results in large number of lines in the atomic spectrum of hydrogen. Now, this is the n is equal to 1 orbit, this is the n is equal to 2, n is equal to 3, n is equal to 4, 5, 6, 7 and so on. When the electrons from the higher orbits fall into the n is equal to 1 orbit, the series of lines that is obtained is known as the Lyman series. When the electrons from the higher orbits fall into the n is equal to 2 orbit, the series of lines obtained is known as the Balmer series. When the electrons from higher orbits fall into the n is equal to 3 orbit, the series of lines obtained is known as Paschen series. And when the electrons from the higher orbits fall into the n is equal to 4 orbit, the series of lines obtained is known as Brackett series. And when the electrons from the higher orbits fall into the n is equal to 5 orbit, the series of lines obtained is known as Pfund series. So, this is how the line spectrum of hydrogen is obtained. So, the Bohr's model of atom could explain the line spectrum of hydrogen. The Lyman series occurs when the electrons fall into the n is equal to 1. The Balmer series occurs when they fall into the n is equal to 2. The Paschen series occurs when they fall into the n is equal to 3. And the Brackett series occurs when they fall into the n is equal to 4. And the Pfund series occurs when they fall into the n is equal to 5. So, we see that the Bohr's model could overcome the drawbacks of the Rutherford's model. It could explain the line spectrum of hydrogen, it could give the energy of the electrons, and it could explain the stability of the atom. But now, this model too had certain drawbacks. So, first let us discuss about the drawbacks or shortcomings of the Bohr's model. This model fails to explain the spectrum of multi-electron atoms, that is atoms having more than one electron. It could explain the spectrum of hydrogen, but it cannot explain the spectrum of multi-electron system. According to Bohr's model, the circular orbits are planar. However, this model says that electrons move around the nucleus in 3-dimensional space. Then it fails to explain the cause of chemical combination and shapes of the molecules arising out of it. And one of the major drawbacks of Bohr's theory was that it assumes a definite knowledge about the position and momentum of electron. The Bohr's theory discusses about the position and momentum of the electron at the same time. Heisenberg was a scientist. He said that it is impossible to measure simultaneously both the exact position and momentum of subatomic particles, and this statement is known as Heisenberg's uncertainty principle. So, Bohr's model could not explain the Heisenberg's uncertainty principle. Then, it could not explain the relative intensities of the spectral lines, that why some lines are dark, some are light. Then Bohr's model failed to explain the splitting of spectral lines on the application of magnetic field, which is known as Lyman effect. This is the Lyman. This is a spectral line. If we apply magnetic field, it gets splitted up. One line is getting splitted up into 3 lines. So, the Bohr's model could not explain the Lyman effect. Then, it fails to explain the Stark effect, that is splitting of single line to a number of closely packed lines in an electric field. That is, when we have an electric field, again splitting takes place. Why it happens so? This model fails to explain the fine structure of spectral lines. And there was another scientist, de Broglie, who said that electron has dual character, that is, it behaves both as particle as wave. But Bohr's model treated the electron only as particle. So, these were the drawbacks of Bohr's model. So, let us revise the drawbacks of Bohr's model. The Bohr's model could not explain the multi-electron system. It could not explain the why we have circular orbits. Then it failed to explain the cause of chemical combination, that why the atoms combine with one another. And the major drawback was that it could not explain the Heisenberg's uncertainty principle, which states that it is not possible to find the position and momentum of a particle at the same time. Then it could not explain the relative intensities of spectral line. It could not explain the Lyman effect. It could not explain the Stark effect, and it fails to explain the fine structure of spectral lines. And according to de Broglie, an electron has both character, wave nature as well as particle nature. But Bohr took into account only the particle nature of particle. It could not take into account the wave nature of particle. So, these were the drawbacks of Bohr's model of atom. So, today we have discussed, firstly we discuss about the Rutherford's model, the drawbacks of the Rutherford's model, that it could not explain the stability of the atom and it could not explain the line spectrum of hydrogen. Then on that basis we discuss about the Bohr's model of atom, that what were the postulates of Bohr's model. Then we saw how it overcome the drawbacks of the Bohr's model, and then we have discovered or discussed about the drawbacks of the Bohr's model of atom. So, this is about the Bohr's model of atom. We have to be very particular. We have to just see the main postulates. Again, I am discussing with you. This is, so the main postulate of Bohr's model was that the electrons revolve around the nucleus in fixed circular paths, and these circular paths are known as orbits, and they are numbered as 1, 2, 3 and 4. Then only those orbits are permissible where the angular momentum is a whole number multiple of h upon 2 pi, and when electron move from higher orbit to lower orbit, they emit energy. When they move from lower to higher, they absorb energy. So, we have discussed about the Bohr's model of atom today, and with that I think we have covered all the important topics. Before that, I have discussed about the spectrum, so that you know what is a spectrum. Then we have discussed about the electronic structure and all. So, that is all about my lecture today. Many thanks to all of the students who have discussed the lecture. Thanks a lot.